When you think of spiders, you might picture a pest to be avoided. But what if I told you these creatures are nature's engineers, producing one of the most remarkable materials known to humanity? This is the spiderweb. In the ancient world, spiderwebs were used by ancient Greeks and Romans to treat soldiers' bleeding wounds. The Aborigines used them for fishing lines for small fish. Until World War II, spiderwebs were used as the crosshairs in optical targeting devices such as guns and telescopes. Now, in the modern world, the use cases of spiderweb have only increased. From nerve regeneration to textile production to bulletproof armor, spiderwebs have found use cases in various aspects. Spider silk's exceptional biocompatibility property makes it an ideal material for medical applications, particularly in wound healing. When applied to lab-grown skin models, native spider silk fibers have been found to significantly improve the development of epidermal layers over fibers and support keratinization. When applied to the burn wounds in living organisms, it has demonstrated superb wound healing properties. The wound healing potential of spider silk fibers has subsequently led to its use in biocompatible sutures for the closure and ligation of various soft tissues during ocular, neural, and cardiovascular surgeries. But not only in medical applications. Spider silk also has generated significant interest in the textile and fashion industries due to its remarkable properties. Traditional synthetic fibers such as nylon and polyester are derived from petrochemicals and are associated with significant environmental issues, including pollution and non-biodegradability. Spider silk, on the other hand, is a natural protein fiber produced by spiders, making it a biodegradable and sustainable alternative. Spider silk's combination of strength, flexibility, and lightweight properties has also captured the attention of researchers in military and defense sectors. One of the most promising applications of spider silk is in the development of bulletproof vests. Spider silk has a tensile strength that rivals steel, yet it is much lighter, which means that vests made from the material could offer superior protection without the heavy weight associated with traditional bulletproof materials such as Kevlar. Spider silk's unique optical properties are being studied for use in gun scopes and other optical devices. The silk's ability to transmit light with minimal loss and its fine structure make it suitable for creating high-precision lenses or other optical components. Spider silk is not only making waves in high-tech industries, but also inspiring innovations in everyday products that we use at our homes. Its potential for producing biodegradable fishing lines is being studied by researchers. Traditional fishing lines are often made from plastic, which contributes to pollution and can harm marine life. Spider silk, however, offers a strong yet biodegradable alternative. The adhesive properties of spider silk have also caught the attention of innovators looking to create more sustainable glues and adhesives. Unlike synthetic adhesives that often contain harmful chemicals, spider silk-inspired adhesives could be non-toxic and biodegradable, making them safer for both the environment and household use. Spider silk's unique combination of strength and elasticity is also being explored for use in musical instrument strings. Traditional strings, particularly for instruments like violins or guitars, are often made from materials that can wear out quickly or are difficult to recycle. Spider silk strings could offer musicians a more durable and sustainable option. The potential applications for spider silk extend far beyond the current uses, opening up exciting possibilities for the future in various fields, particularly in bioengineering and sustainable construction. The construction industry is another area where spider silk could make a significant impact. Researchers are exploring how the silk's strength and flexibility could be used to develop new types of sustainable building materials. For instance, spider silk could be integrated into composite materials to create lightweight yet incredibly strong components for buildings, bridges, and other structures. Looking into the future, spider silk could play an important role in addressing some of the world's most pressing challenges, from reducing plastic waste to advancing medical technology and creating sustainable infrastructure. All spiders can produce silk, but not all spider silk is the same. Spiders can make as many as 7 different types of silk. Making their intricate webs is the most well-known use of their spider silk, but it's far from the only one because not all spiders make webs to catch their prey. However, even spiders that don't make webs have use for silk, such as creating a molting platform, sperm webs for males, and retreats. Most spiders use silk to wrap their eggs. Another common use for silk is a dragline, which is an anchor point used by spiders while it's moving around. Ballooning is another spectacular use of the silk, allowing the mass dispersal of spiderlings in small adults. Spiders even sometimes eat their silken webs and use them to make new silk. Spider silk is stronger than any man-made or natural fiber on Earth. The silk can withstand changes in temperature from -40 Celsius to 200 degrees Celsius. Spider silk is a wonder material that, weight for weight, is stronger than steel, it's tougher than Kevlar, the material used in bulletproof vests, and it can be more elastic than rubber. It's also flexible and antimicrobial. However, the manufacturing of spider silk is not simple, and there are various challenges that come with it. Firstly, spiders cannot be farmed like silkworms since they are cannibals and will simply eat each other if they are in close proximity. As a result, natural spider silk remains incredibly expensive and time-consuming to harvest. Secondly, spiders typically only produce enough silk to make their webs. The silk produced is very fine, so 400 spiders would be needed to produce only 1 square yard of cloth. The silk also hardens when exposed to air, which makes it difficult to work with. Also, spiders produce multiple types of silk for different purposes, such as dragline silk for structural support and capture silk for trapping prey. Each type of silk is produced in a different gland and has distinct properties. Harvesting the right type of silk in the right quantity from live spiders is a complex and labor-intensive process. The properties of the silk can also vary depending on the spider's diet, age, and other environmental conditions, adding additional layers of complexity to the silk harvesting. But scientists haven't given up on spider silk entirely. Instead, they focus their energy on making artificial spider silk and genetically modifying other organisms to be able to produce the stretchy stuff. Now, researchers have successfully gene-edited silkworms to produce spider silk that's 6 times stronger than Kevlar. This heavy-duty fiber may one day be used for surgical sutures, wound dressings, armored vests, and structural materials for vehicles. It could also one day serve as the greener alternative to synthetic materials like polyester and nylon, which shed harmful microplastics and are derived from fossil fuels. Like spiders, the silkworms also coated the fibers with a protective layer that can help them withstand sunlight and humidity. Additionally, genetic engineering has enabled the production of these proteins in organisms like bacteria, yeast, and even goats. However, the yield and quality of the proteins often fall short of what is needed to create silk with properties matching natural spider silk. So next time you see a spider weaving its web, or you accidentally run into a spider web and feel like saying a few curse words, remember, it's responsible for one of nature's most extraordinary materials, one that could shape the future of both sustainability and innovation. Perhaps these tiny architects do deserve a little more admiration and a lot less fear. If you found this video interesting, don't forget to hit the like button and subscribe to our channel for more interesting content. If you know someone who's curious about the hidden powers of nature, consider sharing this video with them.